Hello everyone. In this one we are going to take a look at the Walrus Memory TypeScript SDK and basically build the smallest useful thing that we can with it, which is just an agent harness that writes and recalls memory. So it's about 90 lines of actual code. We'll go through the setup, the 3 calls that make the entire loop, and actually run it, of course. At the end, I'm also going to kill the process and then start it again to see that the agent still remembers what I have previously said. So starting with the requirement environment variables, this is basically everything that the agent needs. The first two are Walrus memory credentials that are generated once at the dashboard of memory.walrus.xyz. First one, the account we see is basically an account that owns the memories. The second, the delegate key, is a key that's registered against that account. And the delegate key is actually what the apps and the agents carry. So in that sense, you never have to hand out the owner wallet credentials. Important to note here is that you can actually revoke those delegate keys at any time that you wish through the dashboard. Then we see the relayer we are talking to, as well as a namespace, and the namespace is basically responsible to separate the different types of memories that are owned under the same account. Lastly, we have the Anthropic API key, which actually has nothing to do with memory and is just basically the model that this agent happens to talk to. Of course, you can swap it with any provider that you like. The memory layer doesn't really care what's generating the text. So from the agent harness, the first thing that we are going to take a look at are lines 24 to 29, which are the memwal client initialization, and that's happening through the environment variables that we just described. Next, really important in this harness, starts from line 98, which is the first step out of 3 of the loop that the agent goes through every time we interact with it. So the first step is recall, as seen on lines 98 to 102. Basically, this is a natural language query. It finds memories by meaning and not keywords, and each one of them comes back with a score. The lower score that we have, the better match it is. So max distance is basically responsible to throw away the weak ones. Without it, we would get back 5, let's say the closest 5 facts, even if those 5 aren't actually relevant. So next step is generate, as seen on lines 108 to 112. And in this step, the memory is going to the system prompt as context. Next and final step is remember, as seen on lines 118 to 127. And in this step, we basically use the analyze function of the SDK that runs an extraction pass and hands back discrete facts immediately. I can use these facts to print them as I do, and under the hood, it embeds, encrypts with seal, and actually uploads each one of them to Walrus as indexed resources. There is one job per fact, and what's important to state here is that the reason we are storing each fact separately and not, let's say, the whole transcript is because we are trying to keep the recall function sharp. So later when you are trying to, let's say, recall a certain fact, only that fact gets back to you and not the entire conversation it came from. And with that being said, let's boot up the agent. I'm gonna run pnpm agent. And I'm gonna start by giving it some information. I am a solutions engineer. I work at Piston Labs on Walrus Memory. Notice that there is no recall line here. So that's of course expected because there's nothing to pull just yet, and it found 3 discrete facts out of the sentence that I gave it. User is a solution engineer, works at Piston Labs, works on Walrus Memory. So Under the hood, each one of those facts is getting its own job, getting embedded, encrypted with seal, and uploaded to Walrus. And all of that work is actually real network work that's done against a decentralized storage network, and that's why it's costing us just a few seconds. Of course, this is not blocking the agent, and we now see that 3 out of 3 are now stored on Walrus. Let me give it a few more details. I prefer PNPM over NPM, and I always use TypeScript strict mode. So I now gave it 2 more facts. It will now extract those 2 separate facts, and notice that it's those 2 and not the entire sentence that I typed. Once again, the reason why we are doing that is because we are trying to keep the recall function sharp. So later on, while I'm conversating with the agent, it will just pull up those 2 distinct facts that are relevant to what I'm trying to do. So now once again, we have 2 out of 2 stored correctly on Walrus, and I think it's time to just kill this process. Kill, clear, and start a new one. PNPM agent. Straight on, I'm just gonna ask it, what should I scaffold a new package with? Let's see what it says. Of course, it's going to recall to find relevant memories. It found 2 relevant memories for my question, and it answered with, go with PNPM since this is your preferred package manager, and make sure to use strict for the TypeScript config. This is correct. And as you can see, I never referred to the keyword of PNPM or something related. It fetched it from the memories and it gave it back as a suggestion. And this is basically what outlines the whole idea. The memory has outlived the process that was basically killed from the previous agent. And the reason why it outlived it is because it was actually never living on the process, but because it was living on Walrus. So that outlines the whole idea.